right, so section is 5.1. Antiderivatives. So this is basically the beginning of Cal 2. So they'll review this again when you start Cal 2, but they do start here. So antiderivatives and indefinite integrals. All right, so the main thing we're going to be using for this section is the power rule for antiderivatives. Okay. All right, so here's the power rule. So suppose you have an integral. This symbol right here means antiderivative or integral. And you have some function, some power function, x to the n, right? Then we'll have so when you see this dx, this is talking about you're integrating with respect to x. The function is in terms of x, and n is some power. So we will say that n is not, oh man, pen's dying already. Hold on a second. Just bought a brand new pen too. N is equal to, n is not equal to -1. It's the only requirement. So if you were to integrate this, in other words, find the antiderivative, the formula tells you that it will be equal to, I'm about to switch pens again. This one worked yesterday. Equal to x to the n plus 1 divided by the result that you found plus some constant c. So that's the rule that we're going to be using in this section. That's how we undo the basic power rule of derivatives. So for example, let's say f of x is equal to, example 1, sorry, equal to 2x squared, right, plus 3. We know that the derivative is going to be equal to 4x, right? Now, the idea is that if I take the integral of the derivative with respect to x, then I will get my original function f, right? So that would be equal to the integral of 4x dx. So what that would give us, right, you say you take the number that's up here, 1 plus 1, and divide it by the same number, 1 plus 1. Then you have some constant c over here. So when you finish this, you'll end up with 4x squared over 2 plus your constant, which is equal to 2x squared plus c. So you see how we found the function, but not the constant. Constant is unknown because you can see that this solution works for any c. The specific c for this question is 3. But since the derivative kind of zeroes it out, the antiderivative doesn't tell you what that c was. you can't find the c without having more information. So like a real life, like physics problem or engineering problem, you would be given like temperature or a starting time or initial velocity or something like that. Then you could find c. Okay. But this is the basic rule that we're going to be using. Just add 1 to the power that you're given and divide by that result. That's all we're going to do. Okay. So let's start some homework questions. Let's see if the black will write again. Maybe not. Okay, so they're giving us the derivative with respect to y. Sorry, derivative of y with respect to x is equal to 3x squared. Actually, 3x to the 2/7 actually. So the idea here is that if I were to integrate dy dx with respect to x, that would give me y. It would undo the derivative. So that's what we're going to do. We're going to do the integral of 3x to the 2/7 dx. So all we have to do is add 1 to this number and divide by the result. So we're going to have 3x to the 2/7 plus 1 over 2/7 plus 1 plus c. Some general c. So that's going to give me what? 2/7 plus 1, that would be 3x to the 9/7 over 9/7 plus c, which would end up being 7/3 x to the 9/7 plus c. That's your result. Reduce the fraction, right? Anyway, you see what we're doing, right? What we're doing is adding 1 to the power and putting that same thing down here. Just do not forget the c. C is some constant.
And is that 7 over 3 on the far right? Or is that 9 over 3?
Yeah, let's see if I can put it down here instead. It'll be 7/3 x to the 9/7 plus c. That's what that says here. Okay.
I think I missed it. How did you get the 9/7?
Oh, you add the fraction. So 2/7 plus 1, you get a common denominator. It'll be 7 over 7 plus 2 over 7. So that's 9/7.
Okay.
And then where did the 7 over 3 come from?
7 over 3. Oh, so when you divide 3 divided by 9/7 will turn into this 7/3.
Oh, okay.
Yeah, I skipped a couple of fraction steps, but yeah, just cancel these guys out and you'll get this.
I wasn't here for the first few minutes of class, but did you mention what the curve meant?
Oh yeah, so this symbol here is saying do the antiderivative of your function. So basically, also known as the integral, it undoes the derivative. So it's going backwards.
Going backwards. Okay, thank you.
So let me show you. So right here is the function they gave us. Find the antiderivative of this guy. In other words, they also call it the general solution because it's a generalized solution here because we don't know what C is. So C is determined by your initial condition of whatever real life thing that's going on. Okay. So we solve for y given a y prime. That's what we did. So here's another one. So y prime equals this. Cancel the derivative and go back to the original function. That's what they want. Find the original function. Does that make sense? Let me write this guy
Yeah, it
down.
does.
Okay. This time I'll use y prime equals 2x to the negative 3. So the question says find the general solution of the differential equation. So a differential equation is basically an equation that has derivatives inside of it, to keep it simple. There's a derivative here equal to some function. So we can consider that a differential equation. Now, what we would do basically is integrate y prime with respect to x. That would give us y, the y function plus some constant of integration. That's what we're going to do. So integrate 2x minus 3 dx. Remember, dx, all that means is with respect to x, integrate this guy. So the rule says, right, you add 1 to whatever power's up here, and then divide by that same result, and add c. That's all we're doing. So that would become 2x to the negative 2 over negative 2, right? Which would then become negative x to the negative 2 plus c, right? So the general solution is negative x squared to the negative 2 plus c. Now, if you take a derivative of this, what do you get?
Negative 2x.
It'd be negative 2x minus 3, right? Power. Did you bring down the negative 2? Is the minus already there? So that would be 2x minus 3. This would be 0 because it's a constant. Notice how this is the same thing that we started with, right? So yeah, it checks out. If the derivative is equal, if the derivative of the antiderivative is equal to what you started with, well, you did it correctly, right? It's like factoring and multiplication, right? You can always check your work. Is there any questions on this idea?
I don't have a question about the idea, but I have a question about, so like we got a glimpse of the answer.
Mhm.
Will you take that answer, or do we have to simplify it to the negative x to the negative 2 is negative 1 over x squared?
Oh, you mean like this power, make it positive?
Yeah,
Yeah, I mean, we should. That's true.
but like, will we get marked wrong? Well, I mean, you're grading our work as we are, like, so if we get to that point, which was
Yeah, I mean,
just algebra.
I would most likely would not mark you wrong for that. I mean, or take anything away. But the homework might. Like on an exam, I mean, I'll know what you meant. Okay. Let's do some ugly ones, I guess. All right, so the integral of square root x plus 1 over 4 square root x dx. So the integral has a similar property just like derivatives do, right? Antiderivatives has the same property. You can integrate these separately. So this is the same as doing this guy by itself plus this guy by itself. You see what I mean? Like when you had a function of a bunch of terms and you took a derivative, it would you would do the derivative of every single part, right? So same thing here. Integrate this guy, integrate that guy, and that'll be your answer. But the square root has to be changed just like on derivatives to a power, right? The 1/4, I'll leave it down there, it's fine. So change this into an x to the 1/2 dx. So I'm gonna have to move that x to the top, okay? Because it's not appropriate at the moment. So let's do one more step to show our work. You can also pull out factors that are constant outside the integrand. And then you can bring this power to the top. Just so you don't get confused. Like, you know, I don't want to deal with the fraction. Let me just deal with this guy. See what I mean? It's the same deal as this. 1/4 came out. Okay. So now antiderivative of this guy. That's going to be 1/2 plus 1 over 1/2 plus 1 plus 1/4 times, I'm going to put parentheses here, that way I don't get confused, x to the -1/2 plus 1 over -1/2 plus 1. And of course I need to add my c. So this will become x to the 3/2 over 3/2 plus, maybe I should start a different page. X to the 3/2 over 3/2 plus 1/4 times x to the 1/2 over 1/2 plus c. Okay. You guys need anything from this side? There's no rush here. All right. So once you've integrated everything, you just got to simplify. Find the antiderivative, same thing. Dividing by a fraction will give you a reciprocal, 2/3. 1/4 divided by a half. Well, actually, fraction would flip, right? So that would become 1/2. So any questions about any of the steps? So all we're doing is that power rule over and over again. It's just that you might have to set up the question like we did with derivatives. When when they were square roots, you got to change them to powers. If they're negative, sometimes you got to change them to move them to the top before you start working. You don't want to do an antiderivative if the number's on the bottom, or the x or term is on the bottom.
On the second term where you have a quarter multiplied by x to the half divided by the half, how you get the half on the third line?
Oh, okay. Basically, it's 1/4 times the reciprocal, right?
Okay.
So this becomes 1/2. So this flips over and multiplies.
Oh, okay.
Okay. So we'll still have integral. No, so now you got to undo and go backwards for the trig functions. I will use theta is fine. For cosine theta plus 7 sine theta. So remember the rules of integrals. You can separate these into two different ones. And then you can pull out the constant outside and deal with it later. So now you got to think backwards here. What's the derivative of sine? Cosine, right? So if I undo the derivative, what should this answer be if I go backwards?
For sure.
Sine.
Sine, right? Because derivative of sine is cosine, so the antiderivative would be sine. So this answer would be 4 sine theta, right? No more d theta. So how do I go backwards from sine though?
Cosine?
It is cosine, but derivative of cosine is negative sine, right? So yeah, I need to build in a negative to fix it. So you see how the idea works? You can also look at your formula sheet that has the derivatives and just think backwards. That also helps. It's just undo what you did. Okay.
This is a lot more like straightforward. Yeah. A lot less writing than right.
Yeah, it's just it's like when we first started derivatives, just doing the basic power rule. So it shouldn't seem too difficult, right? The difficult would be later in Cal 2 when you start applying this to stuff.
And you wrote cosine theta and then d theta?
Yeah, so this is d theta.
Okay.
Let's do one more. Integral of theta squared plus secant squared theta d theta, right? So separate this stuff. So what is the antiderivative here, right? The rule says to do what?
We're in the front.
Right? So what do you do with the power?
We're on the front, I know.
That would be for derivative. What about for antiderivative? The power rule for anti.
Was 2 plus 1?
Yeah, so you got to put 2 plus 1, just like we did the first question, and then you got to put it on the bottom, right?
Mhm.
But the secant is a little bit different. So which derivative gives me secant squared? So I got to think backwards.
Tangent?
Yeah, tangent. So tangent theta is the answer to this integral. Is there any questions on 4 and 5?
So the answer here would be what again?
It would be this one here. I guess I
Oh,
should make
secant
that
square,
prettier.
okay.
Theta cubed over 3 plus tangent theta plus c. This would be the answer.
Mhm.
Okay.
All right. Any other questions on 4 and 5? Okay, let me give you another rule for natural log. So when you integrate 1 over x dx, or you find the antiderivative of x to the negative 1 dx, the answer will be ln of x plus c, absolute value. Okay, so if you see something like this, then it's going to be ln. Okay, so for example, so you have the integral for 3x minus 7 over x dx. That integral would be separated first, right? Pull out the numbers in case they bother you. Then begin the integration. So this would be 3x 1 plus 1 over 1 plus 1 minus 7 ln of absolute value of x. So that's it. That'll be 3x squared over 2 minus 7 ln plus c. And the homework, they want you to take a derivative to check if it's true, but I'll let you do that on your own.
Can you move the paper up just a little bit, please, Mr. Gonzalez?
This or
Yes.
okay. All right. Okay. Now let me do one last one with the where we actually solve for the c given an initial condition.
Professor.
Yeah.
Did some people drop the class?
I think maybe a couple here and there. I don't know about recently, but maybe in the middle or at the beginning of the semester. I do not recall recent. Okay, so let's look at 14 here. Let's do a word problem for fun, right? You guys see this or? Okay. So assume the acceleration of an object is negative 32 feet per second. So that's obviously gravity, right? With what initial velocity must an object be thrown upward from the ground level to reach the top of a national monument 510 feet? Answer to 3 decimal places. Okay. So they want to know the initial velocity. So we're going to have to integrate this guy, because remember how we said derivative of position is velocity, derivative of velocity is acceleration. So undoing the acceleration derivative would take us to velocity. So what we're going to do is integrate that guy. Let me write down this information. The acceleration function is equal to negative 32 feet. Technically, it should be seconds squared. Oh, they said second per second. I guess that's true. It just sounds weird. Okay, and they give us a what? 510 feet is the top of the national monument. Okay. So 510 feet. All right. My neck. No, 1 second. All right, well, let's start integrating first before I think too hard here. Integrate acceleration with respect to time. That would get us to integral of negative 32 dt. I'm going to not write the units for now. That'll give us what? Negative 32t plus some initial velocity. So the constant is going to be the velocity here. This is like my c. So v of t is equal to negative 32 feet, or times, sorry, 2t, plus v naught. Okay. If I integrate one more time, I would get position, which the book uses s. So that would be the integral of negative 32t plus v naught dt, which will give us negative 32t over 2 divided by 2 plus v naught t plus another constant. Okay. So s position function is equal to this here. Negative 16t squared plus v naught t plus some constant. Okay. Now, they gave me a height of 5 something, right? 510.
Like that.
So basically the question is, what must this number be so that C is 570? 1 second. a better way to phrase that. Yeah, I don't think I need this guy. I think we just need this equation here. Okay. Yeah, we don't need position. Sorry. We'll save that for another time. Mainly because I don't have space. Wasn't wrong, just not necessary. So they want to know the initial velocity, right? So wouldn't that mean that the time would have to be equal to 0, or this equation would be equal to 0, and then we can solve for v naught, because it asks for the time. How much time does it take to reach the top of the monument? So yeah. So it makes sense that when I get to the top, I'll no longer be moving, right? Assuming I hit the perfect. This is what I'm imagining, right? I have some monument. I'm on the ground and I'm throwing a ball like this, right? Or whatever. I am not expecting to keep shooting beyond the monument. I'm trying to get to the top. So at this point in time, I should be at 0 velocity, and then I start to go negative, or it should start slowing down the entire way. Here it'd be 0, then it accelerates in a negative direction, so it'd be negative velocity this way. So I should be able to say that this is equal to 0, and then we can solve for v naught. So v naught would be equal to v naught, actually. Sorry, solving for time, not v naught. Yeah, v naught would be over 32. Stupid pen. Some bad luck with pens this semester. Okay. All right. Sorry about that. This logic makes sense to you. The velocity should be 0 at the top. That's why I said equal to 0. And they want to know when, so I'm solving for time. That's the logic I'm using here. Right? Now I just need to find the v naught, because once I have that, I'll know time. So what we can do is use this equation. Okay. Maybe we did need it after all. The integral of velocity, dt, is equal to, let's skip a step since we already did it, negative 16t squared plus v naught t. And then I said we need to know what that c was, right? But they already told us. C is 0 because we're on the ground. This is the height of where I threw it at. this equation should be very familiar. It's the basic parabolic equation for velocity. So I'm just for position, sorry. It's measuring this kind of behavior. Okay, so they told me right off the bat that this is 0 because I am on the ground. So now I know, I don't have to worry about it, that S of t is equal to negative 16 squared plus V naught t, right? And they said that I'm at 510 feet. So at what speed am I hitting that? So replace the t with this right here. In there. And here. So set it equal to 510 and plug in your value. Does that make sense? The last question was a word problem. Figured we would do it. Or is that confusing? So just solve for V naught and we're done. So I don't have any more space here. So I have 510. Has this been done already? Stupid shit. So it has full ink. Okay. So 510 is equal to, what was it? Negative 16 times, let me see if I have another pen. That's ridiculous. See if this one works. Okay. Plus V naught times V naught over 32. So these V naughts will cancel. 510 equals, so this would become negative 16 times V naught squared over 32 squared, whatever the heck that is, plus 1 over 32. So I'm going to multiply by 32 squared everywhere to move that over. So 32 squared times 510 equals negative 16 V naught squared plus 32. I did multiply, I canceled all the fractions. That's what I did here. Subtract 32. So that'd be 32 squared times 510 minus 32 is equal to the negative 16 V naught squared. So just because I'm too lazy to grab a calculator, I'm going to keep going with this here. 510 divided by negative 16. And I'm almost solved it. So V will be equal to plus or minus the square root of this nonsense right here. 32 squared times 510 minus 32 all over 16 negative. So approximately something. Now it's calculator time, right? Should be two answers. One will be negative, so we'll take the positive. 180. Ah, damn, dyslexia. Stupid shit. 180 feet. This way round. Yeah, 3 decimal places. .665 feet per second. Anyway, this was a physics question, is what it was. But we use calculus to solve it instead of a different approach. Any questions with the
Is there going to be a question like this on the test?
I don't know. I haven't looked at it.
I was gonna
Maybe.
ask the same question.
There might be a word problem. I don't know what kind. I haven't looked at the test in a while. I need to check. Maybe.
Oh,
Yeah. There's just 5 questions like this. So
hopefully it's similar, just exactly like this one.
all right, so that's 5-1. So then 90% of it is just power rule, and then you'll have a couple of square root type stuff, and then maybe a few EDX and LN type stuff. I didn't do the EX because you should know the derivative of EX is the same, so the antiderivative will be the same, right? So you're good. All right. Let's take a short break. It's 9:52. Let's continue at 10. Okay. This is 5.2. It's called area. Do you guys remember the summation notation from college algebra? Let me go over it just in case. The sigma notation is used for the sum of n terms, a1, a2, a3, all the way to an, is written as I equals to 1 till n. So the index is the I here, so a sub I. So this means go through 1 plus 2 plus 3 all the way until you get to the last one, which is n. So the summation just means add up whatever's in here until that point. That makes sense?
Yeah, that makes sense.
Okay. Okay, so let's do one real quick. Example 1. Find the sum. So the summation, as we'll use, I guess, k. Doesn't matter what you use. All the way until 6. So k will be used for the index. So it'll be k over k plus 2, which will equal, so you start at 3 and you cycle all the way until 6. Right? So 3 over 3 plus 2 plus 4 over 4 plus 2 plus 5 over 5 plus 2 plus 6 over 6 plus 2. So this is my third, fourth, fifth, sixth term. Okay, so you just add them all up, right? Fourth, fifth, sixth. Oops. Do you understand how the notation works, or do you guys remember? Is there any questions about this?
No, sir.
Okay. Anyway, who cares about adding fractions? But that's what the notation does. Okay. So example 2, let's try going the other direction just so we get used to the notation. Use sigma notation to write the sum. So 3 over 1 plus 2 plus 3 over 2 minus 2 plus 3 over 3 plus 2 plus all the way until I get to 3 over 11 plus 2. So what is the formula that created this sum? The sigma notation for this, right?
Can you put your paper up, please?
Yeah.
Okay, thank you.
So try to find the pattern, right? You see the 3 is constant, so that's not part of the formula. So that's just a 3 that's tacked on, right? Now we got to figure out, where do I start? These numbers are the ones that are cycling or changing, right? You agree?
Yes.
So I'm starting at 1 and I'm going all the way until 11, right? Since I used I will put I plus 2. So that's what this will create, all of the terms until 11.
Okay.
Is that a 7? The last one.
11.
Fraction.
11
top.
plus 3.
Wow.
Yeah, it looks like it's really crappy 3. Okay. So now let me give you the formulas. I believe it's still 5.2, but I forget. Theorem 5.2 summation formulas. So here's number one. If you have a summation from I equals 1 to n of some constant c, it will equal to c times n. C is a constant. Number two, if you have a summation from I equals 1 to n of just a regular I, it will always become n times n plus 1 over 2. Number three, summation from I equals 1 to n of I squared, that will become n times n plus 1 times 2n plus 1 over 6. I'm going to put the fourth one over here, then running out of space. Number 4, the sum from I equals 1 to n of I cubed is equal to n squared times n plus 1 squared over 4. So if you see any of these pop up, just use your formulas.
So what's the purpose behind this? Like,
These
what's it going
formulas?
to do for us in the future?
The purpose is basically these summations will eventually become integrals. And the integrals will find, these summations will be infinite or close to infinite. And since they represent integrals later, you'll be able to find area underneath strange objects or shapes. So you know how in geometry you can find area of spheres, rectangles, etc., no problem. But when you have irregular shapes, integrals will find them for you. And that's where like all those cool 3D programs came in, and we're able to solve that stuff using integrals and sums, etc.
Can I see the last one just one more time? Sorry.
Yeah, it's no rush.
Who's like the professional engineer that has an Excel spreadsheet that does all of this? for them?
Yeah, basically all those formulas in Excel are, already built in. Like the sum that is like a basic command, right? So you wouldn't use these anymore unless it was like the 40s, maybe.
Yeah, I asked my brother, like, because he's a mechanical engineer
Uh,
and he's been one for like 30 years. Like, hey, what's like a good graphing calculator to pick up for me going back to engineering? So he's like, I don't know. I just have a huge Excel spreadsheet that I have every single formula put into. I'm like, oh, thanks, that helps.
yeah, I mean the point of it in as a student is to just understand how they work. So when you create your own formulas or plug them into functions or Excel or whatever, you'll know how they're supposed to fit together. That's the main point.
Can you just overview these ones real quick, just to
Mhm.
see like if you can explain it just briefly? What
Yeah.
each?
Yeah, so if it's a constant, you do a sum. So let's say this is a number 5, right? And you're going all the way to some number n. The sum will always be that number times whatever you stopped at. And if it's an I, I'm going to add I n times, and you'll end up having this. Okay, so there's just if I have an I squared and I'm adding from 1 to n, it'll turn into this guy. So let's say your n is 5, right? You'll just plug in a 5 in here, and you'll have your sum.
Okay.
Who invented this?
What, summations or calculus? Or what are we talking about?
Like this formula?
I don't remember. I think they were derived a long time ago. No one that I recall. But I know calculus was invented by what's his name? Newton.
During a plague.
Yeah. So this one's no big deal, right? You just plug in the number, you add them up 5 times. Who cares? But look at this one. This is a C. So I go for, but this one started at 0. So if I were to adjust this, right, this is 5 different terms. So the answer would be 5C because I'm going from 0 through 4. So that's 5. You see what I mean? Our formula started at 1. So pay attention to the index. Let's see here. Here we're just writing a summation, so who cares? This one would simply be 7 times 7, right? That's what the formula says. Here. Yeah, see? So 7 times 7, 49. Here is an I, right? So you'd have to use the formula for the I. So let's go ahead and do that one. That one looks like it might be worth it. We'll do, yeah, number 6. Example, I don't know what number we're on, 3. Okay. Okay, so you can pull out 2 in front just like you do integrals and just deal with the summation. So the formula for just an I we said was this guy, right? N times n plus 1 over 2. So we're going to have n times n plus 1 over 2. That's what we said? No, I forgot already. Yeah. But n is actually 24. Can't forget my 2, though. So we would get 2 times 24 times 24 plus 1 over 2. These 2's are gone. So that would be 600. So that's what the formula does for you. Is there any questions about that?
We're gonna see this in the test, right?
Yeah.
Okay.
Okay. I think I'll save the complicated part for next time. Let's see here. What time is it? Yeah. So if finish up the 5.1 and start the summation, and then we're going to apply this to the beginning of area underneath a function. Okay. And then we're going to work our way up to integrals to help us find area underneath a curve.
Okay,
All right. You guys have any questions?
All right, no, that'll be it. I saw you extended the homework to May 10. Thank you.
Yeah, no problem.
Can we go now?
Yeah.
All righty. Good night, guys.
good night. Good night, Mr. Gonzalez.
Well, good night.
Good night, everyone.